powers of sine function and of cos function. Okay, so we want to integrate these powers. So let's start with integrating when sine and cos is to the power of 1. We look at the powers of sine and cos. So let's start with sine function. Let's say sine is to the power of 1. We know the integral of sine x is minus cos x. This formulates 1. You know this. Okay. So the integral of cos x, that is to the power of 1 dx, is just the integral of cos x. The integral of cos x is sine x plus c. Yeah? So we know how to integrate sine and cos when it's to the power of 1. It's just straightforward. Okay. Okay, let's look at the sine and cos when they to the power of 2. 2. Okay. What is integral of sine squared x dx? This is the question. Do we have a standard form or standard integral of sine squared? No. So we make use of these identities. They'll be given to you. Sine squared x is equal to 1 over 2, 1 minus cos 2x. And also know that cos squared x is equal to 1 over 2, 1 plus cos 2x. Oh, we use these two formulas. Those identities will be given to you during the test. Okay. And again, this formula coming from this straightforward cos 2x. We know cos 2x is equal to 1 minus 2 sine squared x. You know this identity from high school. And you see when you're solving for cos 2x, for sine squared x, you're going to transpose this and this. So we're going to have 1 minus cos 2x and then 2 sine 2 to the power of 2x and divided by 2. You're going to get this. Okay. So just for simplicity, I'll give them in this form. So it will be straight instead of sine squared x and just substitute this. So I won't give you this identity in this form. Yeah, for simplicity, I will be writing them like this. Here, because we don't have this form, and then we know that sine squared is equal to 1 over 2, 1 minus cos of 2x. So instead of integrating this, we're just going to integrate it. We're just going to integrate its identity because they're equal. Okay, so we're just going to integrate 1 over 2. So instead of sine squared x, we substitute this 1 minus 2x and then dx. And then let's just, because it's easy to integrate its identity, we'll take constant out and just integrate 1. Oh, this is what I'm doing now. This is supposed to be cos 2x. minus cos 2x dx. So instead of this, I substitute its identity now. So now it's simply to integrate its some identity. I take half out, minus cos 2x dx. So let's integrate this. So integral of this is just x, integral of 1, minus cos of a function. Integral of cos is sine of a function, and then divided by 2. We can use the formula from Met 1 when you're integrating cos of a function, okay? And then you set by c. So this is just the basic integral of this. So now we're just looking at when we're integrating sine and cos, and sine is to the power of 2 and also cos is to the power of 2, okay? When I did for sine squared, you try for cos, okay? Cos squared x dx. Try this. Just to give you a hint, because we don't have a standard form for cos squared, so but we have an identity for cos squared. So instead of integrating this, just integrate its identity, okay? All right. So try it. If you can't, or please ask me during the lecture or in your notes under trigonometric functions, integral of trigonometric function. You'll see, I think they have a solution for this, okay? Please. Okay. So here, basically, we look at the powers of sine and cos. We started when sine and cos is to the power of 1. That was straightforward, okay? When sine and cos is to the power of 1, it was straightforward. When we're integrating, when sine is to the power of 2, and we use this identity, okay? And then I ask you to try when this is to the power of 2, okay? Now, let's look when sine and cos is to the power of 3, okay? 3. When we integrate, for example, because I did for sine, let me look at the cos now here. Cos to the power of 3x. Again, we don't have this standard form to integrate this. So we need to do something that will help us to evaluate this integral. So when you have sine and cos to the power of 3, you split one function. If it's cos, you're just going to split one cos here. Cos x, split one cos. Okay. The integral, we just from cos to the power of 3, take one cos out. And then basically here we use this identity, okay, which is sine squared x plus cos squared x equal to 1. Note this. Sine squared x plus cos squared x equal to 1, okay? So want to split the one with squared, you use this identity and substitute 1 minus sine squared x times cos x dx. You see cos squared x here is 1 minus, if you transpose sine squared x here, so you'd see cos squared x equal to 1 minus sine squared x. So instead of cos squared x, because it's equal to 1 minus sine squared x, we just substitute this here. After you use this identity, let me write this. Cos squared x is 1 minus sine squared x. Okay. Yeah. So after you use this identity here, just multiply cos inside. Sine x times cos x dx. Now you're able to integrate this. You know the integral of cos x is sine x. And the integral of sine squared times cos, you have a function to the power of n, and this inner function have its derivative. Here it's just easy. You can just use this formula. I don't know, this f integral of f prime f of x to the power of n dx, integral of this from net 1, n plus 1 over n plus 1 plus c to this one. If you have a function that is to the power of n and that function have its derivative, you can use this formula and just say the function integral is function to the power of n plus 1 over n plus 1. You have a function to the power of n and that function have its derivative, so the integral is just a function which is, we said, sine s to the power of n plus 1, 3 over 3, and then plus c. This is the integral. We use this formula. So basically here, this was the integral of cos to the power of 3, okay? That's how you use, you do when you have cos to the power of 3. And also for sine to the power of 3, we use the same, but again, use the same method. So please try it. I'll give you a hint now. When we integrate, do for sine to the power of 3 dx. Again, you're going to split 1 sine, okay? You split 1 sine here, and then use that identity from above. When you have sine of x squared plus cos x squared equals to 1, you'll see that sine squared x is equal to 1 minus cos squared x. So yeah, you substitute this here. It's 1 minus cos squared x and then sine x dx, and multiply sine inside. Sine x minus cos squared x times sine x dx. So you're able to integrate it. Integral of sine, we know it's minus cos, and integral of the function to the power of n, and the derivative of cos is minus sine. You have minus sine outside, okay? So it will be easy. You use again net 1 standard integral. So please continue. And yeah, that's all. If you check your notes, they did the powers of sine and cos up to when sine and cos is to the power of 5. But I decided to just stop when sine and cos is to the power of 3, because when sine is to the power of 2 or cos is to the power of 4, they're repeating the same as sine squared. When sine is to the power of 4 or cos to the power of 4, they're using the same identity. So yeah, but let me just stop when sine is to the power of 3. And again, when sine and cos is to the power of 5, they use this same again method as they did here. When when sine and cos is to the power of 3, they use this identity. Okay, so let me not complicate stuff. I will stop when sine is to the power of 3. Ne? But again, let's look at just example. Let's apply the above. I did this in class. When you integrate, for example, integrate sine squared of 3x dx. So what is the integral of this? The integral of this, we going to use, again, because we're integrating sine squared. Okay, we don't have a form of sine squared, but we're going to use the same method as we did above for powers of sine. But again, instead of x, we have 3x. But since it's sine squared, we're going to use this identity. When sine is in squared, you remember, when we integrate sine squared, we use this identity. Sine squared x is equal to 1 over 2 1 minus cos 2x. Sine squared is equal to 1 over 2 times 1 minus cos 2x. So as a part of the solution here, before you integrate, you need to find the identity for sine squared of 3x. How do you find this? From this identity, you see instead of x here, we have 3x. So in this identity here, we substitute 3x where there's x. So sine of 3x, where there's x, so it's going to be 1 over 2, 1 minus cos where there's x, we put 3x. So if we put 3x, we're going to have 6x. So this is basically the identity for this one. So the identity for sine squared of 3x is 1 over 2, 1 minus cos of 6x. So now, again, as we saw, we don't have the standard form for sine squared, but of 3x dx in this case. Instead of this, we're just going to interpret its identity. We put the constant out and just interpret 1 minus cos of 6x dx. And again, when we interpret this, this is 1 over 2. Integral of this is x minus integral of cos of a function. It's sine of a function, since the derivative of the inner function is a constant, divided by that constant, plus c. Okay? Yeah, you can stop here, or if you like, you can multiply this half inside. So the answer is x over 2 minus sine of 6x over 12 plus c. All right. Next section, I didn't do this in class today. I'm not supposed to do them now, because I told you I'm only going to record what we did during the online week. But I just thought, let me just include it since it's a part of a trig integration. And first, we're looking at the powers of sine and cos. So now we look at the product. product of sines and cosine. There are four identities that we're going to use here. These are the identity will be given to you during the test. 2 sine of A cos of B is equal to sine of A plus B plus sine of A minus B. The second one is 2 cos of A sine of B equal to sine of A plus B minus sine of A minus B. And the third one is this. You don't have to cram all this because it will be given to you. Eh? 2, just know how to apply them. 2 cos of A cos of B is equal to cos of A plus B plus cos of A minus B. Né? And fourth one, it's 2 sine of A sine of B. This is equal to cos of A minus B minus cos of A plus B. Yeah? Okay. You only use this 4 formulas to integrate the products of sine and cos. Eh? Let's look at the example here. Let's say we want to evaluate this integral. We want to evaluate a sine of 4x times cos of 2x dx. Eh? We want to integrate the product of sine of 4x and cos x. Eh? So we don't have the standard, even the angles are not the same. Eh? So if you have a product, you can use one of these products of sine and cos. You can use one of these formula because we don't have a product integral of the product. If we can just write this product in terms of 2 terms, you see we have 2 terms here, all of them have 2 terms. In the sum of 2 terms, we're able to integrate this sum of 2 terms, because we can't integrate the product. Then we're gonna write our product in terms of 2 terms using this identity. Okay, so to decide which formula we're going to use above, identity that we're going to use above, you check off this form. You have the product of sine and cos. So you want to a formula that have a product with sine times cos. If you check here, sine times cos is this formula number 1. So we're going to use formula number 1, because the formula is cos times sine, and 3 it's cos times cos, and this sine times sine, but we're looking for sine times cos. The order is very important. The formula that starts with sine times cos. So we're going to transpose from the product into the sum of sine. Okay, so from the product to the sum. Okay, how do you use this formula? Okay, you're gonna treat the first angle as A as it is, and the second angle as B. Okay, so let's do the solution here. Let me rewrite this formula above the formula 1. So always we want to evaluate this product. You know you're going to use one of this formula, and then you're going to check which formula we're going to use. As the solution, I see the formula that have a product of sine times cos is this formula. sine of A, cos of B. They said this is equal to sine of A plus B plus sine of A minus B. Okay, so here we want to integrate sine times cos. I check the formula which have sine and cos is this one, and this formula will be given to you. And then you need to choose what is A. You treat the first angle as A and this angle as B and just transform it. But before transform this into this sum, you need to have these two because this identity have two. So what you do here, you introduce 2 here. So you introduce 2 here. We introduce these 2 here because it's another form here, the product. So we introduce 2, but if we introduce 2, we need to divide it by 2. Okay. So now we're happy. We have the form of this formula sheet now in our problem. So here we can able to use this formula. So integral, this is equal to the identity So we're gonna treat this as A. A is 4x and B is 2x. So when you transform from the product, it's going to be sine of A plus B. We said A is 4x and B is 2x. So A plus B is going to be 6x. And then plus sine of A minus B. We said A is 4x and B is 2x. So this will be sine of 4 minus 2x, which is 2x. So we see that's how we use this product. So we're taking from the product to the sum here. All right. So when we integrate this, I'll do this again in class now. When we integrate this, it's easy. We integrate sine. Sine, the integral of sine is minus cos of 6x over 6. Standard one, integral of sine of a function. Check, omit one. And integral of sine of a function, and the derivative of the inner function is a constant. That's why I keep divided by the constant. Just do this straightforward. Okay. So the integral of sine is minus cos 2x over 2. Okay. And then you say plus c. And then you're done. Yeah. I usually don't give marks for multiplication inside, but it's up to you. You can multiply half inside. This would be minus cos of 6x over 12 and minus cos of 2x over 4 plus c. All right. That's how we use basically these formulas. Okay. Let me just do another example. It's just a product of sine and cos. Okay. Example 2. Let's say we want to integrate cos of 5x times sine of 3x dx. Again, we want to integrate the product of sine and cos. So for the product of sine and cos solution, you check which formula have the product of cos times sine and write it down. The formula that has product of cos times sine If we check your formula sheet, cos times sine, you see this is number 2. Okay, so if you see the product of sine and cos, you go straight and take the formula, which according to the problem, in this case they want to integrate cos times sine, so I'll use the formula which have cos times sine. Okay, so this is the formula. I write it down. Is 2 cos of A times sine, and they said this is sine of A plus B minus sine of A minus B. Okay, so now I wanna transpose this from the product, from the product to the sum of sine using this formula. Okay, but I can't use this formula if I don't have 2 here. So I always need to introduce 2 if I don't have 2. So let me introduce 2 here in my problem. 5x so this is my problem. I introduce 2, but remember when you introduce 2 here in my problem, I introduced 2, but I need to divide it by 2, so I didn't effect the value of my integral. But the next thing, I have this now. I will be able to transfer from the product, because the integral of the product I don't have, from the product to the sum of sine and cos, something that will be easy to integrate. Okay, so now let's use this formula now. Once we have 2, we have this form of the formula. You can choose A to be 5x and B to be 3x and just transpose. Okay, this would be 1/2 integral. So this 2 cos of A, we treat this as A, sine of B is sine of A plus B, our A plus B, so the sine of 8x, A plus B. And then minus, according to the formula, sine of A minus B, we said our A is 5x and B is 3x. So 5 minus 3x is 2x, okay? And then dx. And then just integrate this. This now. So this would be 1/2. The integral of sine is minus cos of 8x over 8, and integral of this will be minus cos, that minus will make this positive, cos of 2x over 2, and then plus c. And then you're done. You can just write multiply minus inside, it's minus cos of 8x over 16 plus cos of 2x over 4 plus c. So this is just the integral of this problem that I did, integral of cos of 5x sine of 3x dx. This is the integral. Okay. Thank you. And please be present next week on Monday. I'll be doing application of derivatives. It will be in a test, and the test would be a multiple choice. And thank you.